Hello, Maurits here again. We should look at some more integrals. In this case, we should start with looking at this one. Say we want to integrate x to the power of 3 minus x with respect to x from -1 to 1. So we need to find the antiderivative of x to the power of 3. And that will become x to the power of 4 over 4 minus the primitive function or antiderivative of x, which is x squared over 2 from -1 to 1. We plug in 1 to this, that will be 1 to the power of 4 over 4 minus 1 to the power 2 over 2 minus bracket, minus into this, minus 1 to the power of 4 over 4 minus 1 to the power of 2 over 2 equals 1/4 minus 1/2 minus 1/4 minus 1/2 equals 1/4 minus 1/2 minus 1/4 minus that become plus 1/2. And see, this will cancel against that and this against that equals to 0. So this integral evaluates to 0. So the area should be 0. How come? So let's look at the graph. We go into the graph mode, enter the function x to the power of 3 minus x. Draw. We can see that it goes up like this and down like that. So we have a bubble kind of sticking up there and one down there. And this is -1 and 1. We can check that also by solving the equation x to the power of 3 minus x is 0. We can factorize this. X times x squared minus 1, right? I moved out a factor of x from this. And now we can use the null factor law, right? Either this is 0 or that is 0. Says that. So the first part says that x must be 0, and for the second one, we can see that x must either be 1 or -1. So we have these points exactly as expected. So how come the area becomes 0? And what happens here, if you remember, if you have some kind of function, and we found the area there by looking at the delta x times the height of this, that was f of x. And in this case, f of x is positive, so we find that this little area here is positive. But if the curve is down here, yet again, we have a width delta x, but now the function value is negative. So this little delta x is negative. So if the curve is below the x-axis, the area is counted as negative. If it's above, it's counted as positive. So in this case, these two bubbles happen to be equally big, of symmetry reasons, right? So the area will evaluate to 0. If we just look at the first part, so from -1 to 0 of x to the power of 3 minus x dx, we will get x to the power of 4 over 4 minus x to the power of 2 over 2 from -1 to 0. We first plug 0 into this, that will become 0 minus bracket -1 to the power of 4 over 4 minus -1 to the power of 2 over 2, and this will become 0 minus 1/4 minus 1/2, that is -1/4 plus 1/2, right? Which is 1/4. So this area here, if we look at this integral, this area here is 1/4. And if we would evaluate the integral from 0 to 1 of x to the power 3 minus x, if you do this, you will find the area to be minus 1/4. So these two areas should be equally large, but with opposite sign, and the total area is 0. And this actually does make sense if you think about, for example, from physics, if you have a VT diagram, and hopefully you know that the area under a VT diagram or under the curve is the displacement. And say you have a motion that looks like this. So we have some velocity that then goes to 0 and then to some negative velocity, and that corresponds to, for example, throwing an object up in the air that will turn around and fall down again. And say we start at 20, and this should be in meters per second, and this time could be in seconds. And for the sake of it, we say that g is minus 10 meters per second square. So the straight line here will now be 20 minus 10 t. And say we integrate now from where, by the way, where should we integrate from? We can see that after 2 seconds, 20 minus 10 times 2, that's be 0. So this will be at 2 seconds. And 4 seconds later, it should come back down again. So let us integrate from 0 to 4 on 20 minus 10t with respect to t. 20 will give us 20t. Remember now, as a variable, our variable is t, minus 10 times t squared over 2. From 0 to 4, we plug in 4 into this, so that will be 20 times 4 minus 10 times 4 squared over 2, and then we plug a 0 into all of this, and we can see that that will become 0. So that will become 80 minus 4 squared is 16, divided by 2 is 8 times 10 is 80, and we indeed get the area 0. So the total displacement after 4 seconds is 0. But what is the distance then? So let's evaluate the integral from 0 to 2 of 20 minus 10t with respect to t. Yet again, primitive function or antiderivative was 20 is 20t now, minus 10 times t squared over 2, but now from 0 to 2. That will give us 20 times 2, which is 40, minus 10 times 2 squared over 2, and then 0 into this will give us 0. 40 minus 2 squared over 2, that's 2 times 10 is 20, so that will give us 20 meters. So it will move 20 meters up in there. And then if we would evaluate the integral from 2 to 4, we'll find minus 20. So this will give us 20 meters, and this part here will give us minus 20 meters. So the total displacement is 0. The total distance traveled will be 20 plus 20 is 40. So it's important to remember when you integrate over something, if the function dips below the x-axis, then this part will be counted as negative, and then you're supposed to find the area. You need to find where you have this point and take this area minus this area. But if you just supposed to find the total integral, then you just integrate straight across, like if this would be, for example, a motion of an object. In this case, we don't need integrals because these are triangles, but in principle we can solve it like this. Hope this helps.